Hello there, hello there. Welcome to CXC Math TV, and today we're going to go through Applied Mathematics Unit 1 Paper 2 to help those who are getting ready for the Applied Mathematics Paper 2 on May 25th. Alright, going to try to go through another paper 2, so at least two, and I'm going to be honest, really overworked, and so may not be able to go through more than two, but two should be sufficient as you practice and you can go through all the contents, all applied mathematics content are covered on the channel. You can look through it and it's there. Even though it's a little bit lengthy, but yeah, that's fine. So now 2021 applied math paper 2, let's get started. It says state one similarity and one difference between stratified random sample and quota sample. So one difference between stratified. So first let's start with similarity. Similarity. The similarity is that both use a both use or both rather. I want to make sure my wording is fine. Both both divides the sample into different stratas. Alright, or different subdivisions. Stratas are really subdivisions. So both break it into different stratas. Like a lot of time we break it up by age or we break it up by gender. Those are what? Different stratas or yeah, whatever the case may be. Now the difference now is that stratified random sample, this one as the name suggests is a random sampling technique. Quota now is a non-random sampling technique. So that's the difference. So the difference is that stratified is a random sampling. Well, it's stratified is a random sampling. Well, let's say sample. So don't even say random sampling technique. Say stratified is a random sampling method and or technique, and quota is a non-random sampling method of selecting our sample. Alright, so by the way, if I sound a little tired, guys, it's because it is, well, you see 5:59 right here, and but it's actually 8 o'clock. Alright, so my time is 2 hours behind. That's how I set my computer. It's actually 8 o'clock right now. Alright, and so if I sound a little tired, just bear with me. If you hear any cricket in the background, just bear with me. We're still gonna have some fun. So this part now it says a director wishes to select 20 contestants from 500 applicants for a beauty pageant. Whoa, so some beautiful women, right? Beautiful girls. We love beautiful women. Now it says sampling methods T, U, V, and W are possible ways of selecting a sample of 20 contestants. I want to select 20 beautiful women. Of course, not saying that only women are entering beauty pageant. I'm not saying that, all right? So don't think that's what I'm saying. Now it says name each of the following sampling methods described below. Select equal number of male and female contestants, even though there are twice as many female applicants as male applicants. Now that's already non-random technique. So this is quota. We just want to select equal number of males and females, or proportionate it, or break it up into different groups, and the different groups are male and female, so it is quota. So this is quota sampling method. Now the next one, it says group the applicants by age and select the contestants at random. So notice now the strata is by age. We're doing it randomly, so this is stratified. Once it is random, literally it's just what we did a while ago in part 1. So stratified. Now part 3 now, it says assign a number from 001 to 500 to each applicant and use random numbers to select the contestant. So this is just random sampling technique. So this is random, this is now random sampling, right? A lot of people would call it SRS, all right? The SRS method. Now the next one says first select a contestant randomly from among the first K applicants on the list and therefore select every Kth applicant. Now this is systematic. Alright, these are just notes you should study and know the sampling technique and you'll be fine. This is systematic. Systematic. Systematic sampling. Easy so far, easy 5 or 6 marks. Now on to the next page. Now it says from the sampling methods described on page 4, identify by letter the sampling method which would result in a sampling that is most representative of the 500. Now the one that's most representative is, notice, it's going to be stratified. Stratified is going to diversify everything because stratified, remember we break it up into all age categories, so covering all bases. So clearly it's going to be stratified. It's most representative. Stratified. So this would be the stratified. Oh, but they said identify by letter. Guys, don't even write out the word. You just tell them that would be you. So in our case, it would be you. Alright? Now it says if sampling method U is used, so using the stratified, 4 of the contestants selected from the 500 applicants would be over the age of 50. Let's read that again because I got lost somewhere. If U sampling method is used, 4 of the 20 contestants selected from the 500 applicants would be over 50. No problem. So what they're saying is if you break it up into the different stratas, I don't know what are the stratas, maybe 20 to 30, maybe 30 to 40, maybe 40 to 50, and then let's say 50 and over, and then now it says maybe we have even a less than 20 groups, so maybe let's say 18, maybe 18, 19 years old, right? Let's say these are our different categories to break it up into, right? They're telling us that 4 of the 20 contestants, of the 20 contestants selected, 4 of them are over 50. So that means 4 is in this one, 4 here, 4 here, 4 here, right? So in that case, this would give us, notice when we add them up, we get our 20 contestants. Now let me read the question, what they're asking now. Determine the number of contestants who are older than 50. Okay, so they just want us to tell us now, out of the 500, how much would be over the 50? So remember, from the 20 contestants, we have 4 out of 20. So multiply it by 500. So notice what would be the total then. Pretty much what would be the total that are total applicants. Out of all the total 500 applicants, we want to find out how much women over 50. So we take out the calculator, 4 over 20 multiplied by 500. Nothing big, and that's 100. That's 100. Now it says using the random number using table for the random sampling numbers provided in the list of formulae and the statistical table, we need to start with the first row. So I like to write R1. We're starting from row 1 and the third column, so R1 C3, starting with 36 and move along the row from left to right. List the 5 numbers in order in which they would be selected if the sampling method V is used to select the first 5 of the 20 contestants. Notice we're selecting 5 of the 20 contestants. If we're using the method where we go with 001 to 500, that's the one with V. All right, we're using the random sampling technique. This one, V. Alright, so we need numbers to fall in between this range. Alright, so starting with row 1, column 3. So what we're going to do now is go to our random numbers table. And so random number table. And we need to start with the number. They said row 1, column 3. So this is column 3, and this is row 1. This is the 36 we're going to start with. This 36 is the number we're starting with. And after starting with that 36, remember we're using 3 digits. Back at the paper. And remember it says we move along from left to right. So since we're moving from left to right, our first number we selected, this is the first number, 3, 6, 2. That's the first number. Remember, you go by 3 digits. After the first number, the next number, 688, that cannot help us. That can't help us to put an X. Next number is 811. Remember, the maximum the number should be, remember, it's from 001 to 500. This one can't help. The next one that help is the 133. That definitely help. 133. The next number now, 640 can't help. 823 can't help. Now 320 definitely works. So 320 works. The next number that works is right after the 073. 073. And finally, the last number that works is the 045. These are the 5 numbers. It has to be between 001 to 500. So write those out. The 362nd contestant. So 362. List them out. The next one is the 133. The next one is the 320. The 320th contestant. The next one is the 73rd contestant, 073. And finally, the last contestant selected is 045. 045. Bam! And we're finished. Now it says determine the value of k in the sampling method, W. So W, I think, was the systematic. Yes, W is systematic here. And it says a contestant randomly selected among the first k applicants. Thereafter, we select the kth applicant. So, remember, it's 500 applicants, right? And we're selecting 20 in total. So, if we go 500 divided by 20, so that's what we're going to do on the next page here to get our value of k. So, let me go to the next page. All we're saying here is k is equal to 500 divided by 20, and we'll pump that in the calculator, we'll get 25. So k is 25. So that means all this is saying is that we're selecting our 25th. We are selecting our 25th contestant each time. So what that means is, let's say we had selected the 7th person first. At 25, you then select the 32nd. Then you'd select at 25 again the 15, 59 to 57th contestant. Then we'd go the 82nd contestant, then the 107. And we keep going and we keep going and we keep going until we select the last contestant, which will be the 20th contestant. That's all I was saying. This is a list of how we select them, but it's always the 25th person going along we select from this step. All right. Now, this question now, they said the following table shows the results of a survey of the time taken in minutes by a group of children to complete a reading assignment. All right, so this now we need to complete the cumulative frequency. 8 and 15 is 23. 23 and 22 is 45. So we need to add 45 and 18. So 45 plus 18, that is giving us 63. So we can put our 63 right here. Add 12, that's 75. Add 10, that's 85. Plus a 5 is 90. Now it says on the grid below, draw a cumulative frequency curve to represent the data and use a scale of 2 centimeter to represent 10 minutes on the X and 2 centimeter to represent 10 on the Y. So now they give us this graph. I'm just zooming out to put on the arrows. It's my X-axis. my y-axis. Boom. All right, going back, what's on my x-axis? Time in minutes. I'm gonna write on the x-axis. This is now time, and this is in minutes. And what's on my y-axis? Number of children. All right, so I'm gonna do that one. My y-axis, number of children, or the cumulative frequency. Now don't worry, you're probably wondering about this. I'm gonna rotate it. How do I rotate it? Well, actually, I don't know how to rotate it. So I'm just gonna write cumulative frequency. Cumulative frequency. Now we need to put on, and they said 2 centimeters represent 10 minutes on the x-axis. So every 2 centimeters represent 10. So this is, let me zoom in, because you probably hardly seeing. 2 centimeters represent 10. So this is 10, 20, 30, 40, 50, 60, 70 minutes. All right, and then the cumulative frequency, we're going up to 90. So we can go 10, 20, 30, 40, 50, 60, 70, 80, and 90. That's that. Now we can go ahead and plot these points. Now we have no problem. So plotting 8 to 19. Well, actually 8 to 19.5. All right, but I'm just gonna use the 20. All right, just for simplicity, looking at our graph, you use 19.5. Guys, it's difficult to plot the 19.5, the upper class boundary. So remember, we're going 8 to 19.5. 8 to 19.5. This is 19. 19.5 is in the middle. 19.5. This is our 8, and I'm just gonna plot the correct point. Don't want you to say, oh, sorry, you're doing the wrong thing. Then now, the last, this is 24.5, and we're going up to 23. Remember, cumulative frequency goes on the y. This is your x, where you use the upper class boundary plot. Upper class boundary. So the 19.5, and then the 24.5, and so forth. So going 24.5, that's 23. So 24.5 is here to 23. 21, 22, 23, 20, 21, 22, 23, and this is 24. 23.5 is in the middle. That's it. Then we go, this is now 29.5 to 45. So going 29.5, 29.5 is 29.5 is in the middle to 45. This is the line 45 in the middle right there. Then now we're going, this looks like 39.5 to 63. So 39.5 to 63. Let me zoom out a bit. 39.5 to 63, 61, 62. This would be our 63. So I'll go across from my 63, and I'm looking for 39.5, which is right here. Now I go I'll go 49.5 to 75. 49.5 is here to 75. This is 75. That's my 75. Go across to 49.5 right there. Then we have 59.5 to 85. 59.5 is here to 85. This is my 85. We're going 59.5. That's that. Then finally, of course, we go 69.5. 69.5 to 90. So 90 to 69.5 is somewhere right here. Now, I can't draw the curve very well. So look what I do. I cannot draw the curve, guys. You draw your curve. You're gonna see what I mean. I can't draw the curve. You need to get that ogive shape. All right. Remember, right here, the 10 to 19. You need to get this ogive shape. The lowest was 10, so we'll bring it down to 10. The 0 at 10 right here. Or 9.5 rather. This is our ogive shape. But you notice I don't draw it so good. You make sure you draw it way better than I do. I struggle with drawing these curves. I was gonna just use straight line and connect them, but really struggling. But that's our cumulative frequency. Now it says estimate the median time taken to complete a reading assignment. So to find a median is just like regular math. You divide this into divide the cumulative frequency into 90 divided by 2 is 45. So then you draw your line at 45 going across. At 45 going across is right here. And 45 was in the table, luckily. So we scroll down, that is 29.5 right there. So from our cumulative frequency, when it was 45, all right, this is our median Q2. Our Q2 is 29.5. So determine the median time, 29.5 minutes. That's it, 29.5 minutes. Now it says estimate the interquartile range. Now remember, the interquartile range is equal to the upper quartile minus the lower quartile. It's equal to Q3 minus Q1. So all we have to do now is find Q3 and find Q1, and they will take their difference. So going on, Q3 is the upper quartile, 90 times 3/4. Punch that in the calculator. 90 times 3 over 4. That is giving me 67.5. So we're going to look at 67.5 and go across. 67 point, this is 65, 66, 67, 67.5 is somewhere here. And then we go across 67.5, we'll go across there, and then we scroll down. Mine is in the middle. So my upper quartile that I am getting, remember this is directly down the middle. So this is 41, 42, 43, 43.5. All right, so that's my upper quartile, 43.5. Now my lower quartile is this amount now. I just divide it by 3, and that is now 22.5. You're probably wondering, why did I divide by 3? What I actually did was multiply 90 times quarter. That's how you find the lower quartile. And so that's 22.5. So we're gonna go at 22.5 and go across. So 22.5, this is 21, 22, 22.5 is in the middle. 22.5 in the middle here. So my 22.5 is giving me 21, 22. My 22.5 is giving me 22. So this is now 43.5 minus 22. 43.5 minus 22, which is equal to 21.5 minutes. That's 21.5 minutes. Now it says estimate the proportion of children who took less than 35 minutes to complete reading an assignment. Remember, less than 35 minutes. You're just going to extrapolate from the cumulative frequency. So you're going to go to 35 minutes. I'll change the color to true blue. So look at 35 minutes. We'll go all the way up and then we'll go all the way across. This is now 58. So we get 58 students took less than 58 students gets took less than 35 minutes. So we can just tell them 58 students. All right, that's it. That completes question 1. We did it a little slowly, but it was really my fault because guys, I'm a little fatigued. So if I'm moving a little bit slow, that's fine. It's one of those things. Now on to question number 2. Question number 2, it says identify the measure of variability described in each of the following. It is influenced by extreme values. That's just the range. The range is strongly influenced by, well, yes, measure of variability. Pause. Guys, before we talk about which what would be the answer, remember we're talking about measure of variability, or another word for this is measures of spread. Measures of spread, this deal with the range. So these are your possible answers. Range, interquartile range, standard deviation, variance. Alright, these are what we're talking about. So it says it is influenced by extreme values. The range is strongly affected by extreme values because the range is highest minus lowest. Now it may be obtained by squaring the standard deviation. This is your variance. This variance. Then it says it is the middle 50% of a distribution. The middle 50% of a distribution is what we call the interquartile range. The middle 50%, this is the interquartile range. So we have to know these stuff. Very easy. Now, going down, it says the data below shows a distribution of scores obtained by 20 candidates in an exam. Let's say this was exam scores in applied mathematics paper 2. You have a bright sparks getting 95. You have 85, 70. And then, of course, you have somebody that always just ruin it. Get a 20. Yeah, no. But no problem, right? Now, it says now calculate a 10% trim the mean. So notice so far n is equal to 20. But we need 10% trim mean. So we're going to trim off 10% of this. So 0.1 times 20 is equal to, and we'll put that in our calculator, 0.1 times 20, which is equal to 2. So we trim off 2. So that's equal to 2. So that means now our new n, so the new n is 18. So that means we're gonna need to remove the lowest. We're gonna need to remove the highest. The lowest grade was searching and searching. It looks like 20 is the lowest, and it looks like 95 is the highest. So we'll scrap those. So now the 10% trim the mean. So now 10% trimmed mean is equal to, add up all of those that remain now. So add our 85 plus our 70 plus our 65 plus our 40 plus our 30 plus our 72 plus our 66 plus our 48 plus our 83 plus our 54 plus our 77 plus our 56 plus the 63 plus the 80 plus the 90 plus the 50 plus the 82 plus the 48. We add all of these, and then now we finally divide it by not 20 but the new n, which is 18. I'm gonna bring out the calculator and do that. That's a lot of work in the calculator, man. That's a lot of work. 85 plus 70 plus 65 plus 40 plus 30 plus 72 plus 66 plus 48 plus 83 plus 54 plus 77 plus 56 plus 63 plus 80 plus 90 plus 50 plus 82 plus 48. Next thing I want to do is make sure it's all 18 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Good, it's all of them. And I divide it by 18. So 1159 divided by 18, which is equal to 64.38. So 64.4. That's the average score, 64.4. Now it says determine the modal scores, meaning which one will say occur most frequent. The modal scores, I'm checking which number occur more than once. I see 95 already. 1, 2, that's 2 times. Did anything beat twice? It's 95. Going again, 85 once, 70 once. Now, the best way to actually do this is with a stem and leaf. Stem and leaf for me is the easiest way to can look at it and just tell. So this is just for me. I know I have 20. For the threes is, I know I have what's in the 30. I have a 30. I know for the fours, I notice I have a 40. I take out that. I notice I have a 48 and a 48. Okay. So I already see something else that repeat. Nothing else in the 40s? Nope. So 48 is a possible mode as well. In the 5s, I notice I have a 54, a 56. I notice I have a 50. That's it. Notice in the 60s, I have a 65, a 63, a 66. So notice nothing there help us. In the 70s, I notice I have 70, 77. So basically, nothing else repeat but the 82. Nope, 80. So the only thing repeat is the 95 and the 48. Determine the modal scores, that's 95 and 48. It's what we call bimodal. Alright, so really and truly the stem and leaf, you don't need it. I just put that there to help myself. Cool, cool FM. Alright, easy stuff so far. Alright, this question says calculate the interquartile range. Man, I shouldn't have deleted it, because now we know that the interquartile range is what? Q3 minus Q1. So we need to sort it out so we can figure out Q3 and Q1. So we need to sort it by lowest to highest. So going back, let me take off all the markings. I'm going to sort them. The reason why I'm erasing off all the markings is because I'm going to reshuffle them in order. Alright, so we're going to put back the marking once we take them off. Alright, so starting from the lowest, we had 20. Get that out the way. Then we had 30. Get that out the way. One more in the 30s. Nope, 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 nope. So 40. Get that out the way. Then we had no more 40s, no more 40s. Then we had 48 twice. 48, 48. To get those out the way. Then in the 50s, we have the 50. Any 51? Nope. Any 52? Any 53? Any 54? Yes, 54 is there. And 56 is there. Get those out the way. Then we'll go 57, no, 58, 59, 60. Is 60 there? We're looking for 60. Not seeing any 60, but I see a 63. Then I see a 65. Then I see a 66. Is there a 70? Is there a 68? 70 is there. Then there's 72. Then there's any more 70s? I see 77. We're into the 80s now. We have 80. Then we have 82. Then we have 83. Out the way, out the way. Then we have 85. Out the way. What's leave? 95, 95. Just those two. So 95 and 95. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I didn't miss any. Now for the interquartile range, remember 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the lower half from 65 go down. Then the next one is the upper half. The upper half, the middle value in the upper half, give you now the interquartile range. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divide it right here. 1, 2, 3, 4, 5. This is 80. Then 1, 2, 3, 4, 5. This is the next 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So in between 80 and 82 is 81. That's the upper quartile. So the upper quartile Q3 is 81. Minus for the lower quartile, splitting it in the middle, 1, 2, 3, 4, 5. This is that. And the next half is from 50 going up. So in between 48 and 50 is 49. And then we subtract them and we get 32. And remember that's 32, right? Marks. Now they want the standard deviation. Now remember the standard deviation, which formula I want to use. Let me see. Um, Can't bother with the stress. So the formula that I am going to use, I'm going to use this one, which is the sum of xi squared, and this is over n minus bar x squared square rooted. This is the formula I'm going to use for standard deviation. It's going to work out a bit easier. But first thing though, you have to tell them what is the sum of xi squared. So what you do is add up all the square values for all of these numbers. So we need to add up all the square values for all of these numbers. We can tell them here. So telling them this is 20 square plus 30 square plus 40 square plus 48. Notice 48 square repeat twice, so we can write 2 in bracket 48 square just to show that it repeats. You don't need to add 48 square twice. Plus 50 square plus 54 square plus 56 square plus 63 square plus 65 square plus 66 square plus 70 square plus 72 square plus 77 square, and we're out of space. 77 square plus 80 square. Alright, out of space, so I can't. So I'm going to stop at 77 square, then continue from there, plus 80 square plus 82 square plus 83 square plus, what's next after 83? We have 85 square plus 95 square, and it's two of them, so 2 times 95 square. Whew. So much work. That's 89,991. So this is now 89,900 and how much we say? 89,911. So now this works out to be the standard deviation is 89,911 over n which was 20 minus bar x we said was by the way we don't know bar x. By the way, do not use this value as bar x. This is the trimmed mean. So from the trimmed mean, look how we're gonna find bar x fast. This question is a lot of work. 1159 was for the this was when we add the sum for the 18, but we had took out the 95, so we'll put in now the 95 plus now we're gonna put in the 20 and now we're gonna divide it by 20. So this is actually the mean, 63.7. The 64 is the trimmed mean. So the true mean is 63.7 and we'll square it and then we'll square root it. So now the standard deviation, we'll put that in the calculator. Square root fraction 89911 over 20 minus, this is now open bracket 63.7 close bracket and we square it. I'll work that out and that is 20.9. So this is 20.9. That's the standard deviation. Of course, and my computer is about to shut off, so I have to plug it in. Alright, so I plug it in now. And now the next thing it says is that we need to give an interpretation of the value that we computed for our standard deviation. So let's give an interpretation. So an interpretation, this means on average, so this means on average, each score deviated from the mean by 20.9. That's what the standard deviation is. It's saying on average we can expect each score to deviate from the mean by roughly 20.9. All right, that's so on average each of the 20 scores deviate from the mean by 20.9. We don't know if it's marks or percentage, so you just put 20.9. Part C. Part C, it gives us this right here, and it says, the following shows the frequency distribution of the number of eggs per tray in a random sample of 50 trays. Determine the median number of eggs per tray. So the first thing we have to create is a little extra column right here called cumulative frequency. Create an extra one called cumulative frequency. This is 4. Add 10 to 4, that's 14. Add that, that's 34. Add 11, that's 45. Add the 5, that's 50. Remember, the median is the one in the middle. So if you divide 50 by 2 and then add 1 to it, because remember it's half n plus 1. Right? So this is 50 plus 1 is 51. Half of 51 is 25.5, which is a 26 egg. So the 26th egg, when it's sorted, that gives the median. That would give the median. Now the 26th egg would be in this group, right? Because remember, this is 14. So from 15 to 34 is there. So in that case, the median number is 14. Right? That's it. Alright, so what they're saying is, yeah, 4 of them will have 12 eggs, 10 of them with 13 eggs, 20 of them with 14 eggs. The median is 14. Determine the mode is which one occur the most frequent. The highest frequency we see is 20. So in this case, the mode is 14 eggs. Now they want us to find the mean. Now always remember mean now. This is so easy, guys. So easy. Remember, oh, don't need to zoom that big for me. Remember the mean is bar x. Bar x is equal to the sum of fx over the sum of f. So the sum of fx, we need another. Well, we can just work out fx here. This is your x, so them tell you x, and this is f. This is x, this is f. So now we work out 12 times 4 plus 13 times 10 plus 14 times 20 plus 15 times 11 plus 16 times 5, all divided by the sum of f, and which we know that is 50. So now can start working out the numerator. Working out the numerator, it's 12 times 4, which I know is 48. Don't know why I'm using the calculator. 13 times 10, which we know is 130, plus 14 times 20, we know would be 400 minus 20 times 6 is 120. That's 280. 14 times 20 is 280. Plus the 15 times 11, which we know is 165. Plus 16 times 5, which we know is 80. And add them, that's 703. We'll divide 703 by our 50. And we get 14.06. So notice we're getting roughly 14. Now, this is it, 14.06. I just want to make sure this is perfect with that. This was just to add them again. Want to make sure it's perfect. That was 48 plus 130 plus 280 plus 15 times 11, as we said, was 165 plus 80. Yeah, so we know it's 14.06. It says describe the shape of the distribution. Now always remember a distribution is symmetric when the mean is equal to the mode and it's equal to the median. Now since the mean is equal to roughly 14.1, right? And 14.1 is what? That is bigger than, greater than the mode, and the mode is equal to 14, don't? And so in this case now, remember the skewness formula is mean minus mode, right? Mean minus mode give you skewness, but mean minus mode in this case is greater than 0. So this is slightly positively skewed. So what are we going to say? Since the mean is greater than the mode, the distribution is slightly positively skewed. Just marginally, slightly positively skewed. Right? That's it. So it's very close to being normally distributed or symmetric. Nice. Now this question now it says events A and B are such that the probability of A is a quarter, the probability of A given B is 5 over 8, the probability of B given A is 3 over 5. Find the probability of A intersect B. First thing remember is that the probability of A given B is 5 over 8. The probability of A given B is the probability of A intersect B divided by the probability of B, so that is 5 over 8. But then they told us the probability of B. Did they tell us the probability of B? Actually, they didn't. So we can't start with that one. My apologies. My apologies. We can't start with that one. So the one we're going to start with is this one. Alright, so the probability of B given A is the probability of B intersect A over the probability of A, and they tell us it's 3 over 5. But then the probability of A is a quarter. So that means that the probability of A intersect B, which is the same as B intersect A, when we divide it by a quarter, we get 3 over 5. So we can cross multiply, so the probability of A intersect B then is a quarter times 3 over 5, and so that is 3 over 20. That's our answer. Now they want us to find the probability of B. Now the probability of A intersect B divided by the probability of B, remember that gives us a probability of A given B. But that then means that, remember, the probability of A intersect B is 3 over 20. And then we divide it by the probability of B, we're getting the probability of A given B, which we know is 5 over 8. So we can flip them, so the probability of B then is equal to, do the math, we just flip it, it's 3 over 20 divided by 5 over 8. And I'll just put that in the calculator to save time. 3 over 20 divided by 5 over 8, which is 6 over 25. I will finish. Now we want the probability of A union B. Now the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. The probability of A, which was a quarter, plus the probability of B, 6 over 25, minus the probability of A intersect B, which we know is 3 over 20. I'll punch that into the calculator. A quarter plus 6 over 25 minus 3 over 20. And so that gives us 17 over 50. This is 17 out of 50. That's our answer. Easy so far. Module 2 is a breeze. Remember, Module 2 will start. This is the probability part of the paper. Probability. Managing uncertainty. So now it says state whether A and B are independent and give one reason for your answer. Now remember, it's independent if the probability of A times the probability of B give us the probability of A intersect B. So first thing, let's work out the probability of A times the probability of B. Notice that would be a quarter times the probability of B is 6 over 25. And so if you work this out, this is 6 over 100. And 6 over 100 is 3 over 50. But this is not equal to the probability of A intersect B. The probability of A intersect B is 3 over 25. See there? 3 over 20. And this is 3 over 50. So in that case, A and B are not independent. That's the reason right there. We did it. We showed it by computation. A and B are not independent. That finish out this part of it. Easy. 3, 6, 8, 10 easy, easy, easy marks. It doesn't get any easier than module 2. I need to lean back my back, so it's coming back a little bit. Now this question here, this is a probability distribution question. It says find the value of B. Remember, everything must add up to 1. So 0.15 plus 0.25 plus B plus 0.2 plus 0.15 is equal to 1. And we'll add them. 0.15 plus 0.25 plus 0.2 plus 0.15. We'll add them. That's 0.75. So 0.75 plus B is equal to 1. So B is just 0.25. Alright. 0.4, 0.6. Yeah, B 0.25. That was so easy. Next, they're going to ask us, I'm guessing the expected value of X. They always see there, the next going to be either the variance or the standard deviation. Yep, I know. Always ask the same thing. The expected value of X, remember, the formula is the sum of X times the probability of X equal to X. So in that case, now it's going to be 1 times 0.15 plus 2 times 0.25 plus 3 times B, which is 0.25 plus 4 times 0.2 plus 5 times 0.15. I'll put that into our calculator. 1 times 0.15 plus 2 times 0.25 plus 3 times 0.25 plus 4 times 0.2 plus 5 times 0.15. And so work that out and we get in 2.95. This works out to be 2.95. That's it. Easy, that's the expected value of x, 2.95. Now, the next part, they want us to work out now the variance. Now, you have to remember this formula. Var x is equal to the expected value of x squared minus the expected value of x all squared. So now we need to work out the expected value of x squared, which is x squared times the probability of x equal x. So this is now 1 squared times 0.15 plus the only difference between here and here, we'll put in now 2 squared times 0.25 plus 3 squared times 0.25 plus 4 squared times 0.2 plus 5 squared times 0.15. And we'll plug that into our calculator. Very easy. Only difference now, change them here to square. Oh, I bring up everything in the power. I didn't want it to do that. 5 squared times 0.15. This part, I need it to be 4. Not like that. It's not doing what I want it to do. 4 squared times 0.2. Not gonna write 3 squared, and I'm just gonna put 9. Then not gonna write 2 squared, I'm just gonna put 4. And 1 square is 1. Now 10.35. And then now we can tell them, oh, so now var x then is going to be 10.35 minus expected value of x. And then we square it. So now we have 10.35 minus 2.95, close the bracket, we'll square it. And this is what we get for the variance. The variance is 1.6475. Pretty straightforward. Now it says right here, a bag contains 5 blue counters and 7 yellow counters, who are drawn from a bag one after another, and it says without replacement. Draw a probability tree diagram. So notice the bag has what? It's either going to be a blue counter, I'm going to write the letter B for blue, or it can be a yellow counter, either blue or yellow. Now after that, remember we're going to draw 2 from the bag. First, remember it starts with 5 blue and 7 yellow, so the total is 12. Now to get a blue then is 5 over 12. To get a yellow is 7 over 12. But this would be on the first draw. Now on the second draw now, what happened? If you draw a blue first, you can then either draw a blue next, or you can draw a yellow. Or it is that you could draw the yellow first, then you draw a blue next, then a yellow. Now if you draw the blue first, and getting another blue is 4 out of 11. But remember, one of the blue would already be gone. Alright? Now, to get the yellow now, you don't take any yellow, so it's 7 out of 11. Now, if you had get the yellow first, if you had take out one of the yellow first, then 11 would be left back. And so to get a blue would be 5 out of 11 because we don't trouble any blue. Now, if it's yellow, then yellow. If you take out a yellow, 6 yellow leave from the 11, so 6 out of 11. Alright? And that is that. Now, by the way, always remember it helps if you know when you're doing past papers, make sure you finish study. If you don't finish study, then a question gonna feel difficult. You're gonna wonder what's happening. Make sure you finish study the syllabus and all the contents, watch all the videos, do all the practice questions before you do past papers. Now this question now it says use the diagram drawn, determine the probability that the counters drawn are different color. So it wants us to find the probability we get blue and yellow. If we get blue and yellow, it can be that we get the blue first, then the yellow, or it could be that we get the yellow first, then the blue. If we get blue first, then the yellow, it's this way, blue then yellow. So 5 over 12 times 7 over 11. Plus, if we get the yellow first, it's 7 over 12 times 5 over 11. I'll put that in our calculator as the probability of getting different colors. So 5 over 12 times 7 over 11 plus, of course, 7 over 12 times our 5 over 11. That's giving us 35 over 66. 35 over 66. Easy. Nice. Okay. Now, the next question now. By the way, we finished question 3. Was that easy? Question 4 now, it says a credit union found out that 25% of its customers do not make their monthly payments on time. A random sample of 20 customers taken. Anytime you're given P and N, it's binomial. To identify the distribution that may be used to model this situation, it's a binomial distribution. Always remember, once you get N and P, it's binomial. And X follows a binomial distribution of NP. Good. Now, once you get mean and standard deviation, it's a normal distribution. So we just have to know these things, guys. So state our parameters. All right. So our parameters, all right, our parameter P that we know now, or proportion, found out that 25% of the customers do not own their monthly payments. So we know P, which is 0.25. All right, that's a proportion. That's a parameter that we're using. That's our parameter P right there. All right, cool. Now the next part, it wants us to determine the expected number of customers. So always remember your expected value of x for binomial distribution is n times p, is 20 times 0.25, and you punch that in the calculator. 20 times 0.25, which we know is 5. So this is 5 right there. So determine the expected number of customers, 5 customers. All right. That is that. All right. No problem. Now it says calculate the probability that exactly 5 customers do not make their monthly payment. So the problem, remember, x follows binomial distribution of 20 n p, and p is 0.25. So to find the probability x equal to 5 now, the formula, remember, is n. Remember, let's just to write down the formula so you remember it. Probability of x equal to, common letter x is n choose x, p to the x, q to the n minus x. So this is 20 choose 5, 0.25 to the 5 times 0.75 to the 15. I'll put that in our calculator, all of it one time. 20 choose 5. I'm going to do it separately. 15504 times 0.25 to the 5th, which is 1 over 1024, times 0.75 to the 15, which is 0.013. And then now multiply that by 1 over 1024 and they will multiply that by 15,504. And so that is our answer. It is roughly 0.202. That's a probability of x equal to 5, which is approximately 20.2%. There's a 20% chance that exactly 5 persons do not make their payments on time. Now it says V, calculate the probability that at most, so calculate the probability that at most, meaning that's the maximum, at most mean maximum. So that means at most 3 customers do not make their monthly payment on time. So if it's at most, its probability X is less than or equal to 3. This is then the probability that nobody make the payment on time, plus the probability 1 person make the payment on time, plus the probability 2 person make the payment on time, plus the probability 3 person make the payment on time. Each will give us a mark. So this, remember, is 20 choose 0, and it's 0.25 to the 0, 0.75 to the 20. Now when it's x equal to 1, it's 20 choose 1, 0.25 to the 1 times 0.75 to the 19. Plus this one is now 20 choose 2, 0.25 squared times 0.75 to the 18. Plus the last one is 20 choose 3, 0.25 cube times 0.75 to the 17. Then you put all of that in your calculator. It's 4 marks. I'm going to put all of it in the calculator one time. So putting it all in the calculator once, we have 20 choose 0 multiplied by 0.25 raised to the 0 times 0.75 raised to the 20. I'm going to do it one by one. I didn't want to do it one by one. 3.17 times 10 to the negative 3 plus, change it now from 0 to 1. The reason why I'm doing it one by one, it's easier to do this. Change it to 1, change this to 1, change this to 90. To type everything in the calculator one time can be tiring. That's 0.021114 plus this one now, changing it to 2, that's now 0.0669, 0.0669 plus, changing it to 4, changing it to 3, sorry, not 4, 317. Ooh, this is 0.1339. Now I can add them. So this one plus 0.0669 plus 0.02114 plus 3.17 times 10 raised to the negative 3. And there's a 0.225. This is 0.225, which is approximately 22.5%. There's a 22.5% chance that at most 3 persons do not make their payment on time. Whew, tiring. Now it says a new director was appointed and decided that a larger random sample of 100 customers would be better. So now N is 100. Using a suitable approximation to determine the probability that no more than 35 customers make their monthly payments on time. Now, anytime n times p is greater than 5, right? Remember, p is still 0.1, 0.25. And if we work out 100 times 0.25, You get 25. Anytime n times p is greater than 5, we approximate to a normal. So now we're going to approximate to a normal distribution. So now we approximate to normal distribution. It's so much to remember. Now we approximate to normal distribution. So in this case now, x is going to follow a normal distribution with mean, and the mean is our expected value of x. And then now our standard deviation, remember, is the square root of Rx. So first thing we need to find is the expected value of x, which is n times p, which is 100 times 0.25, which is 100 times 0.25 is, why am I doing it mentally? No, that's 25. Now var x, not the square root of var x, it's just var x goes here. Now var x is n times p times q, which is 100 times 0.25 times 0.75, which is, we work that out, 100 times 25 times, not times 25, times 0.25 times 0.75, and we get 18.75. That's our var x. So that means x follows a normal distribution of 25, 18.75. Now we need to find the probability that no more than 35, the probability x, no more, that means maximum less than or equal to 35. Now since it says less than or equal to 35, alright, remember, equal to 35, we're going to add half to it. So when you standardize it, you're really trying to find the probability x is less than or equal to 35.5 when you standardize it. Well, not really standardize it, but when you look at what we call the continuity spectrum, alright, the continuity spectrum allows us to go up to 35.5. So in this case now, it's equal to the probability of, standardize it. This is now z less than or equal to 35.5 minus, this was 25 divided by the square root of 18.75. I'll put that in our calculator. 35.5 minus 25, and we divide it by the square root of 18.75, and we get 2.4. So this is now equal to, the probability z is less than or equal to 2.42. Then we'll go into our normal table now. So we'll go to our normal table, which is going to be on, which page is the normal table on? Here's a normal table, and we're looking for 2.42. This is 2.4, 2.42. The overlap at right here, which is 0.9922. So that's our answer, 0.9922, which is approximately 99.22%. So there's a 99.22% chance that, where are we? How we reach unit 2? Alright guys, I just have to scroll back a bit. I'm at unit 2, I made some blunder there. So there's a 99.22% chance that that happened. Now part B, it says the length of a javelin is normally distributed. So another normal distribution question. The length of a javelin is normally distributed with mean 240 and variance 64. Now find the probability that it will measure more than 255 centimeters. Probability X will measure more than is greater than 255. So that is now the probability Z is greater than 255 minus 240 divided by the square root of 64. Right? Now, we work that out. So 255 minus 240, and we divide that by the square root of 64. Punch that in the calculator. That's 1.875. This is the probability z is greater than 1.875. Now if you draw what the normal distribution look like with mean 0 and variance 1, this is what we have, and we want when it's greater than 1.875, which is this small piece. So in that case, it's going to be equal to 1 minus the probability z is less than 1.875. So now we just look in the normal table for 1.875. So this is a normal table. This is 1.8, this is 1.87, this is 1.88. So in between those two would be 0.963 and 0.9699 is 0.9696. So this is 0.9696. So that's what we're going to do. This is 1 minus 0.9696. We subtract, and we get 0.0304. That's our answer. Easy. Now it says now, javelin that are less than 220 are cut and sold as fence posts. Calculate the percentages of javelin that will have to be cut and sold as fence posts. To find the probability that x is less than 220 is equal to the probability z is less than 220 minus the mean. The mean given was 240 divided by the square root of 64. Punch that in the calculator. 220 minus 240, and we divide that by the square root of 64. That's negative 2.5. I want to make sure I do that right. Negative 20 divided by 8. Yep, negative 2.5. So now find the probability z is less than negative 2.5. If we draw this again, negative 2.5 is somewhere here. And the probability z is less than that. So in this case now, if we want the probability z is less than negative 2.5, it's just equal to 1 minus the probability z is less than 2.5. So now we look at 1 minus, we look at 2.5 in the normal table. 2.5 is here, which is 0.9938. So this is just 1 minus 0.9938. You'll punch that in the calculator. 1 minus 0.9938, which is 31 over 5,000. Multiply this by 100. This is 0.0062 as a decimal. 1, 2. Yeah, that's our answer as a decimal. Or some people would approximate it as a percentage and say 0.62%. That's it. So less than 1% is going to get thrown away, no problem. That finish out question 4. Alright, so it's really not bad so far. It's very easy. Now question 5. Question 5 now it says the weight of the bags of apples are normally distributed with mean and unknown variance sigma. Calculate unbiased estimator for the mean and the standard deviation. So remember, bar x is now the sum of x over n. This is now 1600 divided by 150. We'll put that in our calculator. 1600 divided by 150, which is 32 over 3 or 10.6. That's 10.6. Now the standard deviation is equal to the square root of, the formula is the sum of x squared minus the sum of x all squared divided by n all over n minus 1. This is now the square root of the sum of x squared, which is 18040, minus the sum of x, which is 1600 all square over n. 150 divided by n minus 1, 149. I'll pump that into the calculator. This is just bunch of formulas to remember. 18040 minus fraction button, open bracket, 1600 square divided by 150 over n minus 1, which is 149. We'll check that out. We'll square root it. We'll get 2.56. That's 2.56. And they didn't tell me the weight, so I don't know whether to put kg or grams, or I don't know what's the weight of the bag of the apple. Now it says state an approximation of the sampling distribution. Always remember now, bar x gonna follow a normal distribution with mean. The mean mass was 10.6, and then standard deviation square. So 2.56 square would give you the variance. That is it. Oh, and then we divide it by n, of course. We divide it by n. Alright, so 2.56 square divided by n, and n was 150. So now they say determine an approximate of 95% confidence interval. And remember, confidence interval formula is bar x plus or minus z alpha over 2 in brackets sigma over the square root of n. Alright, now in that case now, remember we're using 95% confidence interval. So our significance level is 5%. Alright, so now we're looking at 0, but remember we divide it by 2, so 0.05 divided by 2 is 0.025. So really what we're looking for is z of 1 minus this, we're looking at z of 0.975 in bracket sigma over square root n plus or minus bar x. So bar x, remember, was 10.6 plus or minus. We're looking now at 97.5% in our z table. So look at where can we get, we're looking for 0.975. 975, 975, 9, so here we go. That's 1.96. This is 1.96. So now we have plus or minus 1.96 in bracket. Standard deviation we had gotten was 2.56. So 2.56 divided by the square root of n, and n was 150. This is now 10.6 plus or minus. So work out now our margin of error. So 1.96 times in bracket 2.56 over the square root of 150, close the bracket. Our margin of error is roughly 0.41. 0.41. So that means what's determine the confidence interval? When you subtract the lower value now, so 10.6 minus that, give us 10.19. So 10.19, comma, and then the higher value now, the higher limit, or 10.6 plus 0.41, that is giving us 11.01. That's our answer for the confidence interval. Very easy. Just to remember a bunch of formulas and 3 easy marks. Now it says an inspector wishes to test whether the mean is 11. That's what the inspector believes. So state your null and your null hypothesis. So your null hypothesis HO, the null hypothesis HO, this is our null. Alright, so we're stating, of course, that the mean is 11, but we're always trying to disprove that statement. So our alternate now, our alternate is going to be, we don't think that it's 11. We do not believe it is 11. That's our alternate hypothesis. Now, we need to determine our critical value at 10% significance level. So because it's a two-tail test, all right? I know this is not 100% perfect. at 10% significance level, this is what we have. This is what we call our rejection region, anything outside there. And this 2 water shade adds up to 10%. This is 0.05, this is 0.05. Alright, so these are what we call now our rejection region. We'll add them up. But we need to find this value. What is this value? That's our critical value. This Z value right here is our critical value. Alright, so now, alright, we're looking at, ouch. So to find our critical value, we're working out Z of alpha over 2. Alpha is 10% or 0.1. And so 0.1 divided by 2 is 0.05. So we're looking at 0.95. So now, alright, so 0.95 is what we're looking for. 0.95 in the table, 0.95, 0.95, 0.95. 0.95 is in between. This looks like 1.645. This is 1.645 we're getting. Alright, notice it's at 95% when the Z value is 1.645. So in between, so 1.645. This is 1.645. So the critical value is 1.645. Now it wants us to determine our rejection region. 1.645. Now our rejection region, this would be negative 1.645. So rejection region is when, so we reject two cases. We reject when Z is less than minus 1.64 or when Z is greater than 1.64. I'll put on the 5. Alright. Now it says, given that the test statistic is negative 1.59, what can we conclude? By the way, this right here can be written as the modulus of Z is greater than 1.645. So now in this case now, let's test it out. So we have negative 1.59. Is it, the modulus of that, is it greater than 1.645? Is it greater? So no, that is not true. So 1.59 would be in here. Somewhere right here is 1.59. So it's inside the not reject region. So no. So since the modulus of this is not greater than 1.645, then we fail to reject the null hypothesis. So we fail to reject the null hypothesis that the mean is 11. 11 what? I don't even remember 11 what. That the mean is 11.0, yeah. So we fail to reject the null hypothesis. That's it. Now this question now, it says another hypothesis testing. Whoa, they're giving us a lot. Now it says a simple random sample of 14. By the way, n is 14, which is less than 30. Automatically, we know we're going to use what now? T distribution. So now we're using T distribution. Alright, and they carried out at 5%, whether the average BMI is less than 35. Now identify the distribution that we can use to model. So remember now, let's say X follows, it's going to follow a T distribution now. It's following a T distribution with n minus 1 degrees of freedom. And of course, our mean is, where's the mean? Our mean is, they say it's 35. Oh, it don't even want us to write down the distribution. It says keyword, identify the distribution. We're going to tell them the T distribution. We're using it since the sample size is small. So we use a t distribution. T distribution. I have difficulty spelling sometimes. And the reason is because the sample size is small. That's why we use that. T distribution, that's because the sample size is. Now it says determine the critical value. They jump straight to it. It always asks that the critical value. Now, critical value notice is at 5% significance level. Alright, so if you draw, always draw this, guys. It helps you draw. It's a one-tailed test. Since it's a one-tailed test and we're looking at less than 35 on the left side. So right here is your critical value, and it need to be at 5% significant level. Right off, all of this supposed to add to 0.05. So we need this value right here. This value right here, but you can find, let's find this value first, and then the negative of it will give us. So 5% significant level, so we'll look at 0.95 in our normal table, subtract it from 1. So 0.95 in the normal table already had established that at 0.95 is 1.645. So we'll go back to the paper. This right here is 1.645, but we're over this side, so it's negative 1.645. So what is our critical value? Negative 1.645. So from our normal table, we can tell them critical value is negative 1.645. That's our critical value. Now it says determine the rejection region. The rejection region is when z is less than z alpha. Alright, so when z is less than z alpha, in that case, when our test statistic should be less than negative 1.645. So now it says, given that the mean is 30.5 and the standard deviation is 10.6, calculate your test statistic z. Now our test statistic z, remember, is bar x minus mu divided by sigma over the square root of n. So in that case, bar x, remember this is t distribution, this critical value. I didn't even mention the n minus 1 degrees of freedom. My apologies, guys, where the degrees of freedom would be 14 minus 1, which is 13. So my total apologies. I was using normal table, and this is a t distribution question. So I need to look at 13 degrees of freedom, and this is 0.95. So it's actually 1.71, guys. My apologies, it's actually 1.71. So see there, 13 degrees of freedom, it's 1.71. So don't put this, please. It's 1.71. So look how I'm giving it away. I'm approximating to normal distribution. The negative 1.71 is 1.71. Almost give it away. Almost, guys, but we'll get to fix it. Don't worry. Don't worry. We got to fix it. The negative 1.71. Right here now, negative 1.71. So now working this out, bar x is 30.5 minus the mean they gave was 35 divided by the standard deviation 10.6 divided by the square root of n, and n is n is 14 divided by 14. They'll pump that in the calculator, fraction button, 30.5 minus 35 divided by fraction 10.6 divided by the square root of 14, which is negative 1.58. That's our test statistic. No, negative 1.58 is our test statistic. All right, so next thing they're going to ask us is to make a conclusion. I guarantee you. That's the next thing they'll ask. Make a conclusion. See, their state a conclusion. Now, your conclusion is going to be based off your rejection region. So negative 1, if you look back at it, where's negative 1.58? Negative 1.58 is in here. So we fail to reject the null hypothesis. So since negative 1.58, look at this, negative 1.58, right? It's supposed to be less than negative 1.71, but we know this is what? False. Since it's false, we cannot reject the null hypothesis. So we're going to tell them we fail to reject the null hypothesis that, then what was the null hypothesis again? We'll go back and we fail to reject the null hypothesis that the average BMI is less than, the average BMI is equal to 35. So we fail to reject the null hypothesis that the average BMI is 35. Okay, excellent. So we fail to reject the null hypothesis. That's it. Now, question number 6, it says, sociologists selected at random. It have 140 leaders to investigate the effect of different leadership styles on the satisfaction of employees. An assessment was made of the leadership styles and the workers. And it says an assessment was made of the leadership styles, and it says on workers. The test statistic listed below. It says a chi-square test is carried out to determine whether the leadership styles affect the satisfaction level of workers. So write your null and your alternate. The first thing we're going to write is our null, HO, and what we're saying is that we always have to first say that the leadership style does not affect, leadership style doesn't affect the satisfaction of our workers. So leadership style does not affect satisfaction level. SL means satisfaction level of workers. Need to bring this over. Bring this over. So leadership style does not affect satisfaction level of our workers. Then our alternate now it's going to be, of course it does affect. So now the alternate, which is our H1, let's call it H1, is that our leadership style does affect satisfaction level of our work. Alright, so that is it. That's our null, that's our alternate. Now it says complete this table now. Now, completing the table, first thing is I need to have my row total and my column total to help me. Now, this is 30 and 24 is, please tell me you have the total down there. Yeah, because I couldn't bother to add. Only thing they should have gave me now, this is 45, this is 60, and this is 18 and 17 is 35. So just to have my row total, I need to put the low is 45. This is going to help. Oh, let me put it here. 45. This was 60 and this is 35. Now we need to work out these expected values. To work out those expected values, remember the formula you're going to use is row total times the column total divided by the total. So the row total is 45 times the column total, 72 divided by the total was 140. So you put that in your calculator. Row total 45 times 72 divided by 140. That's 23. This is your expected value, 23. Now this one now, our row total is the same, but our column total is now 68. So the formula would be 45 times 68, and then we divide that by 140. So this is now 22. Here now, working out now, this is now row total 60 times our column total 72. Let me just use fraction button, it makes it easier. So 60 times 72 divided by the 140, that's 31. And over this side now is the same row total, it's just that the column total change. Column total is 68, and we get 29. Then here now, row total 8, that's 35, times column total 72 divided by 140 is 18. So this one's spot on. And then the next one should be 17, but just to verify, 35 times 68 over 140, yes, 17. Notice these add up to 72 and this add up to 68. Alright, nice. Now it says calculate your chi-square test value. Now your chi-square test statistic, your chi-square value, remember it's equal to the sum of your observed value minus your expected value squared divided by your expected value. That's how we work out our chi-square test statistic. So it's our observed value minus our expected value square over our expected value. Alright, so in that case, we have to work out all of these. 30 minus 23 square over our expected value. Now, come on, stop it, man. Guys, I'm just gonna write down the difference square because we should be able to know, we should be able to follow at this level. We're sixth form students doing applied math. 30 minus 23 is 7. So that's 7 squared over the expected value was 23 plus 24 minus 31 is still 7. So 7 squared over 23. I know it's negative 7 plus this 18 minus 18 is 0 plus 15 minus 22 is negative 7 squared over our expected value was 22 plus this one is 36 minus 29, that is 7 squared over or 29 plus this one 17 minus 17 is 0. So now we'll work out all of that. 7 squared over 23 plus this is now negative 7. I'm not going to write a negative 7. I'll just put in the 49 over 23 plus 49 over 22 plus 49 over 29. So I'll work out the squares there. Waste of time to put that in the calculator. So now it's 8.18. This is our test statistic of chi-square. Whew. Now that we get our chi-square, it says determine now the critical region. So I love when you draw your diagram. Guys, you know me already. I love drawing the diagram. Right? This is something like that. Right? And at 5% significance level, at 5% significance level, all right, so let's say this is our rejection region or 5% significance level. We go and we're looking at our chi-square. And first thing, we need to work out our degrees of freedom. I didn't work out the degrees of freedom. Remember, your degrees of freedom is going to be right here. It's 1, 2, 3. It's really, remember, it's row minus 1 times column minus 1. And it's 1, 2, 3 rows. So 3 minus 1 times how many columns? 2 minus 1 is 2 times 1, which is 2. So 2 degrees of freedom. So here, for this part, our degrees of freedom is equal to 2. So we're looking at 2 degrees of freedom. All right, we're looking at 2 degrees of freedom. And then we'll go all the way over to 5.91. All right, we'll go to 5.91. That's our critical value. All right, so we look at 5.91. Come back to here. Determine the critical region. All right. So this right here determine our critical or our rejection region. All right. So from this now, notice this right here, this value right here is going to be our 5 point. Going back to it. This is our 5.991. 5.991. And so in that case now, we notice that this is the area we reject. That's the 5% we reject. Now in that case now, our chi-square value, which is equal to 8.18, it's greater than our 5.91. Since it's greater, guess what? We reject the null. 8.9 is in this piece. It's in that shaded part. It's in the rejection region. Right? Oh, don't answer the question here. That asks for the critical region. The critical region, the critical region is when your chi-square is greater than 5.991. That's what we're saying. So don't put this part, just put chi-square greater than 5.991. Now what can we conclude? State clearly conclusion that may be drawn. So because we realize that our 8.18 is greater than 5.91, our test statistic lie within the critical region. So we can tell them since our test statistic lie in the critical region, we can reject the null hypothesis that the something about satisfaction level of the workers. But all we know is that we reject the null hypothesis. So we reject the null hypothesis, or reject the null hypothesis that the leadership style does not affect. So we reject the null hypothesis that the leadership style does not affect the workers, something about the workers' mood or something like that. Worker satisfaction level. And we finish. Now the next part, now it says a random sample of 384 provided at a 95% confidence interval for a proportion with a margin of error 0.05. Approximate the value of P. So first thing they tell us is n is equal to 384. Now remember, confidence interval formula, the confidence interval formula is bar x plus or minus Z alpha over 2 in brackets sigma divided by the square root of n. And then this part is what we call the margin of error. That part is what we call the margin of error. Guys, go and check out the video we have on confidence interval. So this is the margin of error, and it tells the margin of error is 0.05. But this is also proportion question. So margin of error for a proportion question is C alpha over 2 in bracket. This is PQ over n square rooted, and it tells us that is 0.05. So in that case now, first thing, this is at 95% confidence interval, and we divide it by 2, so it's really 0.975. And I remember we already looked at this, that was the 1.96 in bracket. P and Q is 1 minus P over N. N is 384. And then remember, we square root it, and this is 0.05. So it's just transposition. Divide now, I'm getting P times 1 minus P over 384 is equal to 0.05 over 1.96 squared. Then I cross multiply some more. I get P times 1 minus P is equal to 384 times the 0.05 over 1.96 squared. This is transposition, guys. What an easy question. This is literally just mathematics now. I know applied math is math, but it's the first we're doing so much math. 0.05 over 1.96, close the bracket, square, and this is what we get, 0.25. So that means P times 1 minus P, 0.25. I need a little more space. So we have, let me just take out this. As I said, that should be the notes. It's supposed to know that is margin of error. So finishing it here, all right, we have so far, carrying it back up, we have P times 1 minus P is 0.25. Expand that in, so that means we get in minus P squared plus P, bring over 0.25, that's minus 0.25 equals 0. Now guys, I don't have time to be solving no quadratic, so I'm just going to bring out my calculator and go to mode. Solve a quadratic for me, please. Solve this equation, it's a quadratic. Coefficient of A is minus 1. Coefficient of B is 1. The constant is 0.25. First answer, that don't make no sense. Probability can't be greater than 1. Next answer is negative 0.2. That can't help with either. So clearly something went off. I check back again. This is P minus P squared equals 0.25. And if I bring it over, if I brought it over the other side, it would be P squared minus P plus this. So A is minus 1. Let me change it to the actual. Oh, that's the mistake. It's minus 0.25. Because I was just saying there's no way we made a mistake there. So minus 0.25. So half and half. Whoa. So P is just half. It worked out so pretty. P equals 0. Guys, I love when question work out so pretty. P is just half. I should have known half times half is quarter. I'm losing it. Half times half is quarter. We should have known. Half times half is quarter. So this is half. P is just half. So now that we get that out the way, this question now, the paper almost finished. It says a random sample is this. Calculate the sample mean. The sample mean is add up everything and divide by n. So take out our calculator. There's nothing really to do, but just add. So the sample mean is 16 plus 14.2 plus 14.4 plus 14.3 plus 14.6 divided by 1, 2, 3, 4, 5. And we do that. And they want sample variance too, that's a lot. 16 plus 14.2 plus 14.4 plus 14.3 plus 14.6. Then we divide that by 5. That's 14.7. That's the sample mean. 1 mark. Now the sample variance, S squared, remember it's equal to this is now the sum of xi squared minus the sum of xi. Remember this is all square over n. Then we divide it by n minus 1. I just slapped a bat because my window is open, so don't worry about me doing that. I saw a bat, small bat, slap it. So now continuing, working this out, this is 16 square plus 14.2 square plus 14.4 square plus 14.3 square plus 14.6 square. That is this amount 1082.65. 1082.65 minus what was this again? The sum of xi. The sum of xi, if we want to find that out again, that was 14.7 times 5, which was this amount, 73.5. We're going to square that, then we divide it by n, which is 5, then we divide that by 4. Plug all of that in the calculator to get our variance. Fraction button, 1082.65 minus fraction button, open bracket, 73.5, close the bracket, squared over n minus 1. And this is our answer. 11 over 20 is the variance, which is 0.55. Now it says determine the critical region for a null hypothesis against the alternate at 5% significance level. So that's the critical region they want. At 5% significance level. So in that case now, guys, so much time they ask 5% significance level. In that case, our z value, or z alpha over 2 is 1.96. We did 5% significance level earlier on in the question. That's how I know it's 1.96. All right, so in that case now, if we draw it, all right, what we're saying then is this is 1.96, this is negative 1.96, and it's a two-tailed test. So our rejection region, determine the critical region. So our rejection region is when z, or test statistic, is less than negative 1.96, or when z is greater than 1.96. That's our answer. Finish, finito. And guys, that completes this. This completes the Applied Mathematics 2021. All right, a very easy paper. Hope this video is beneficial, guys. It's now 9:55 p.m. So I'm signing out. Make sure to just hit the like, hit the subscribe if the video helped you. Wish you all the best prepping for your exam. And also, finally, any content that you feel like you need some revision on, look through the channel, look for hypothesis testing, look at all of those things. All right, all of those things is here. Sampling, distribution, just look at them and you should be fine. All right, so I'm signing out now.